So now that we've solved for this equation using coding and found that there's no restrictions on what u values and therefore what dx and dt values we can use, we want to see why that is true. What we want to do is get this down to something where we can tell that dx and dt and therefore u do not matter. It does not cause any issues with the graphing. So to do that, we're going to do the same process as we did before by using the answer t equals I k delta x e to the negative alpha k squared t. And as before, t j n is equal to e I k j delta x e negative alpha k squared n d. And also, tj plus 1 n is going to be equal to e I k delta x times tj n, as we showed in the previous videos. Also, tj minus 1 n is going to be equal to e negative I k delta x tj n. And now we want to know what to do with these n plus 1 terms. So as you can see, tj plus 1 n plus 1 differs from tj n plus 1 by this j plus 1, and therefore an e to the I k delta x. So you know that tj plus 1 n is going to be equal to e to the I k delta x t to the j n plus 1. This is n plus 1 also. As well as tj minus 1 n plus 1 is going to be equal to e to the negative I k delta x tj minus 1, or tj n plus 1. So now that we have all these in terms of, in just down to 2 terms, we're going to plug them in up here. So that gives us well, on this left side, we're going to factor out the tj n plus 1. That gives us tj n plus 1 times negative u e to the I k delta x plus 1 minus, or 1 plus 2u minus u e to the negative I k delta x. And this is going to be set equal to tj n times u e to the I k delta x plus 1 minus 2u plus u e to the negative I k delta x. So now that we have these factored out, we want to get these values, just the u, e, I, k delta x values, all on one side. And so we're going to have that on the opposite side of the n plus 1 because that's what we want to check. This is going to give us tj n plus 1 to be equal to tj n times u e I k delta x plus 1 minus 2u plus u e to the negative I k delta x all over negative u e I k delta x plus 1 plus 2u minus u e to the negative I k delta x. So now that we have this, as we did the explicit differencing, we're going to use Euler's rule to exchange these e's for a cosine x plus I sine x form equation. So now that we have this equation displayed above, we can use Euler's law to combine these 2 terms. So if you remember from previous videos, u e to the I delta x plus u e to the negative ik delta x is equal to 2u cosine k delta x. We proved this in previous videos using Euler's law. So now we can plug this in above and simplify. That gives us tj n plus 1 equals tj n times 2u, or actually let's start with the 1. 1 plus 2u cosine k delta x minus 2u. As you can see, I've just split up the 1 minus 2u so I can combine them in the next step. And that's going to be over 1 plus 2u 1 plus 2u minus 2u cosine k delta x. And so as I just said, I want to factor out this 2u here. So that's going to give us a tj n plus 1 is equal to tj n times 1 plus 2u times cosine k delta x minus 1 over 1 plus 2u times 1 minus cosine k delta x. So as you can see, the top and the bottom are almost identical. However, it's just offset by a negative. So what we want to do is take this negative out from the top so we can get this 1 minus cosine k delta x on the top and the bottom. So this is going to be equal to tj n times 1 minus 2u times 1 minus cosine k delta x over 1 plus 2u times 1 minus cosine k delta x. And this will be a very useful function for us to be able to see that it does not matter what u is, and our function will be able to work. So 1 minus cosine k delta x. As we know, at its minimum, cosine can be negative 1, and at its maximum, cosine can be 1. So this term will never be negative here. And so because of that, we have 1 minus a non-negative number over 1 plus a non-negative number. This is always going to be less than 1. This function right here is always going to be less than 1. And so because of that, we know that tj plus n, no matter what values you put in for u, it is not going to steadily increase no matter what. So this means, and we can rearrange this to see this more easily. So we'll have tj n plus 1 is equal to tj n times 1 minus w over 1 plus w. And for this here, I've substituted 2u times 1 minus cosine k delta x for w to give a more simple version. So as you can see, if w is always greater than 0, but less than 1, then that means 1 minus w over 1 plus w is always going to be between 0 and 1. So because of this, we know that there will never be any problems based on your input values of dt or dx, thanks to this Neumann stability analysis of the Nicolson method.